Visit us at Eduvvo. Thank you for calling Eduvvo.
If we restart our app here, just to get rid of that error which I deliberately produced, we will see that we now have a nice working first app. Of course, it doesn't really make a difference which answer we choose, and after the third answer our app breaks. These are all things we can and we will tackle, but other than that, we covered a lot of the core important features which we need to know. Now I want to take a step away from Flutter again and have a look at a Dart specific feature. A feature which we already saw when we had a look at this colors thing. There, if I clicked on it, you saw that this is a class which essentially groups a couple of static properties, which are properties we can access without instantiating the class, which therefore ensures that the class is basically like a grouping mechanism for these utility values which are provided out of the box. That's not the thing I want to primarily look at though. It's this const keyword here instead, because we saw something similar already. In our answer widget, we also have final. Now, both final and const sounds like we're creating values which can't change, right? A constant value is probably the opposite of a variable. It's a variable that doesn't change, hence it's pretty constant in the value that's stored in it. But a final value also is a value that doesn't change. So what's the difference? Let me go to the main Dart file. Here, this questions list here, in the end, is a constant, if you will. Why? Because the values here never change. Okay, but isn't that the same as final? Indeed, we can use final instead of var here. And actually, that would be better than using var, because now we're really clear about the fact that we never intend to change these values once our program runs. That's the important thing. You use final if a value doesn't change from the point of time when your program runs. It can be initialized with a value though. For example, in our question and answer widgets, the properties here are final because they are changed initially when we assign a value here when this gets created, but they don't change thereafter. Here in main Dart, we're creating a question and we're creating the answers, and when we select a new question, in the end, Flutter reruns this build method here because we call it setState, and therefore it rebuilds this tree and it rebuilds all these widgets. It creates a new object, a new instance of the question class, for example, and it passes a value to that, and therefore the value that gets passed here into this question text property is kind of dynamic. Once this question widget has been created, it never changes, but when it is created, it's a different value than for the last question. Okay? I guess that makes sense. So it's kind of dynamic. At runtime, the final value gets locked in, but at the point of time we're writing the code, so during development, and also when our code gets compiled, the value is unclear, because the question widget can work with different question texts. Only when it then runs, a certain text is locked in. That's exactly what final means. It's a runtime constant value. At the point of time this code executes, we lock in final values. But at the point of time we're writing this code, we don't know what the final value will be. Well, because it's really important, for the question widget, for example, there is not a single final value. It depends on the concrete instance we create. It's different for the questions list here though. We never change this list. Yes, we select different questions here when we output our questions, but we don't change our question list here. We just get access to it to then show it somewhere else. We get access to the question text to then show it somewhere else. We don't change the questions list here. And therefore, this is not just final, but it's const. It's constant. Hence here, we should actually use const to make it really clear that this is compile time constant, not runtime constant like final is, but compile time constant. Now, compile time constant also implicitly means runtime constant. If you know at the time you're writing the code what the final value will be, and you know that this value will never change, then of course it will also never change during runtime. Okay? But the value, the final value, is not locked in when your code executes, but already after you wrote the code, because this questions list will never change. And that is a important concept and hopefully makes it clear why you see both final and const and how they differ. Now, besides adding const here in front of the variable name, you can also, by the way, add it in front of a value. And now what's the difference? The difference is that if you add it in front of the variable name, the variable is constant. If you add it in front of the value is constant. But isn't that the same? For that, you have to understand how Dart manages your objects. All your objects, no matter if it's a list or a widget or any other object based on any other class, all these objects are stored in memory by Dart. And what it actually stores in your variables, where you think you store the objects, what Dart actually stores in the variables are the pointers at the objects in memory. So the addresses of the objects in memory, you could say. And if you consider a real-life example, if you have a house and you go to the postal office and you want to send a letter and you need to put your address on the letter as well, well, of course you put your address on the letter and not your house. Now, this might sound like a dumb example, but in the end, that's exactly what's happening here. Instead of bringing the object itself to every place in your code that needs it, which would take up a lot of memory because you would constantly have to copy it and so on. Instead of doing that, Dart is pretty smart and stores the object only once, somewhere, and then only takes the address in the different places. It's in the end also what we do with answer question with this function. In the end, the function also is just a variable which holds an address to this function code, you could say. And therefore, we can pass this address, this pointer, as I also called it, at this function. We can pass this to our widget where we then bind it to onPressed, because onPressed now has the address of the code it wants to execute when the user clicks the button. And that's not just the case for functions, but for any object. Now, when we turn a variable into a constant, it implicitly also treats the value as constant. But you could do the opposite. You could have a variable questions and still have a constant value. And now what would be the result of that? Now what is allowed is that you assign a new value to questions. You could set questions equal to a new list now. And even if it's an empty list. This is technically a new list. It's a new object in memory. It's not the old list without elements. It's a new list. It's a new object. And I stored this new object in questions, and therefore what I actually stored in questions is the address of the new object. But what this means is that the old value of questions, which was the address pointing at the old object, is overwritten. Now, by the way, for the rest of the course, I will always say we store an object in a variable, we store a list in a variable, even though technically we store the address. But saying it in the other way is simply easier. But that's important to understand. We had the address here, now we're overriding it with a new address. This is allowed if questions is a variable, even if the value here is constant. If I change questions to be a constant, however, I will get an error down there, because now I'm trying to assign a new value to a constant variable, and that is not allowed. So that is why we should use const here if we never want this to change, because then we avoid dumb mistakes like accidentally assigning a new value. So this does not work if questions is a const. But what's about that const value now? For that, let me give you a brief other example. Let's say we have a variable, dummy, and that is a list of text where I have hello. Now, what I can do is I can call add on the list. Add is one of the methods that's provided on the list object. And I can add a new value, and therefore if I print dummy here, and that reloads, I see hello max being printed here, because I print the full list and I added the item to the list. Important, unlike map, add does modify the original object. It does modify the original list. So here I modify the original list by adding a new item. If I added const here, this would not work. If I add const here and I save this, now I get an error. During compilation, because it's a compile time constant. So during compilation, I get an error that I cannot add to an unmodifiable list. And that's great. So you should always be pretty explicit about your goals in your code. And if you know you have a list where you maybe want to reuse the variable and assign a brand new value to it, that would be allowed because it's a var. But where you never want to change that object, then make the value a constant. If you have a list where you know the values will never change, well, then make the whole variable a constant so that both the variable and the list is protected against changes. And if you have data where you know it will not change once it has its initial value, then make it final. Now, these were a lot of new concepts, and of course it's a bit overwhelming right now, which is why we will, of course, use all these things throughout the course, and therefore it will become more and more natural to work with final and const. I found it important to introduce this right now, though, because I want you to learn and write clean code right from the start, and you will see final and const a lot in Flutter classes, in other examples, and also in this course.